Okay, good. If you're at the assembly and you're missing how to use a protractor, you get to live it live with us. Okay. Kevin, don't say anything bad or it's going to be recorded. So here we have this picture. And which one looked like it was leaning more to the right?
The one on the right.
Of course the one on the right looks like it. The question is it actually? And some of you may know yes or no, but let's check. Easiest way to check, of course, is how do you measure lean or angles with a protractor? Now, a protractor has certain rules of use that are really non-negotiable. So you have a protractor like this. All of your protractors will have the angles spread from 0 to 180 or 0 to 180, goes in both directions. And there's some kind of target point, and there's also some kind of set line, baseline, where your 0 and 180 lines up. So the key is using it correctly. So when you're actually using a protractor, you need always, how many line segments? One? Can you do it with one? Can't measure an angle with one. You need at least 2 line segments. So where are the 2 line segments in this picture? Well, one, we can actually use the base of the picture. So right along here, use this bottom edge of the picture. That's one of your segments. The other segment, though it's not that easy to see on your printout, there is a dashed line that runs through this little Mitsubishi sign here and all the way through to the top. So if you look at that dashed line, and put that there on purpose, that's your other segment. Now actually what I drew here is kind of sloppy, so just use the bottom edge of the picture. Occasionally when you use your protractor, you have a situation sort of like this. Let's see here. Where the protractor is too big and it doesn't quite line up, where your lines are too small, you can always extend it. You can always use the bottom of it as a straight edge. But for now, we have our 2 segments, the bottom and this dashed line. And the key is, you need to put your target exactly where those 2 segments meet. So they meet right here. You try to center your target right there. Now, the reality is, the more careful you are, the more you realize that the protractors sometimes have issues. They have little holes punched that are slightly off-center. The black lines are supposed to be the truest guides, but these are not high-end protractors. So you're going to have some error in the manufacturing process. That's a good sig fig problem right there. How many sig figs does the manufacturer use in making these? Charles Leonard. All right, anyway, beware. It cannot be over here. It cannot be over here. It has to line up right at that target point. A second issue sometimes people have is they put the base or the bottom of the protractor on that bottom segment. That's not right. The target needs to be there. Now the final issue with lining it up is tilt. If you have it a little bit tilted, something like this. No, here we're staring at it, it's easy to see that's tilted, but when you're home and you're working fast, or I see some of you working within the binder, it is sometimes difficult to get the protractor to fit right. If it fits right on this one, fine, but beware, if you have to angle yourself or if the paper is curved up a bit, getting this lined up is going to be a problem. So make sure that you are fully lined up. There we go. That's pretty good. Now, here is perhaps the most important tip for using a protractor. Count. Just like rules on moving decimal places based on exponents and rules for sig figs, you've learned all these different rules for things. Go back to basics. The basic thing that you can do is count. You were very good at counting before you were able to do anything else mathematically. What angle is this right now? We think. What angle though? I mean, it runs through a couple numbers up there, so which one is it? What's that? 100? Somewhere around 100?
Yeah.
So you could say it's somewhere around 100. Or, anybody else have a different feeling?
80.
You could say it's around 80. Here's the way to remove that issue. Yes, you can be, I know, acute, obtuse, and the rest of that. The simplest thing to do is just count. You will not make a mistake counting. So if you go to here's your 2 segments. Go down here and start. Just count in groups of 10. Your protractor is marked every 10 degrees. Doesn't matter what it says on there. 10, 20, 30, 40, 50, 60, 70, almost to 80. Mine on this picture looks like, I can actually read one more sig fig here. Mine looks like 79.5 degrees. Yours may look like 80. When we transfer from Word to this smart notebook, the sizes adjust slightly. Do yours look like 79.5 or 80? There's also thickness of the line. You say, well, wait a minute, where on the line? So there's lots of little issues you get into when you try to get particular. But count. You may say, oh, that's easy, I didn't need that rule. But when you get an angle that is something like this, and it goes through this spot right here on the protractor, are you going to know that it's 45 as opposed to 55? You may not notice that when you get near 45 degrees, but counting will always get it right for you. So let's go over here. What about this one? What angle? Practice the same process, set it up at the spot. That's that little spot right there. And then count. 10, 20, 30, 40, 50, 60, 70. Ooh, looks like 79.5 degrees again. Yes? Okay, so which one is leaning more?
They're the same.
What's that?
They're the same.
They're the same. These two are the same. Just for fun, in case you like this, anybody like working with illusions, that sort of thing? You might. Take a psych class in college on it. Actually, probably talk about it in psych classes here. So, Mr. Weissman talked to you about this stuff. Do you know why it is that this one appears more lean than this one? Anybody have a feeling on that? Yeah?
Is it because this one's more shaded?
Is the one on the right is more shaded. And you have another feeling. I'm just going to hold it. I'm not saying right or wrong.
Isn't the picture on the right like shifted a little bit?
Picture on the right is like kind of like tilted a little or something. So within the picture, the angles are the same, but the whole picture is kind of tilted. You can say the same thing?
I'll say the way it was taken the picture.
So it's kind of like a different angle that the photographer stood. Okay, yeah.
I think it's just because it's on the right side, it looks like it's gonna tilt a bit more.
So the right looks right. That is the closest to the right answer, actually. This is a fun one, and that's why I bring it up. Basically, you have this. Your brain is pretty good at judging vertical. However, when you judge lean, when you say how tilted is something, you always compare it to the nearest vertical object. So when you look at this one, the nearest vertical is just this line right here. Is a nice contrast, dark and light, big white, big dark blue. And so this in your peripheral vision is vertical. And so clearly this is off vertical. You see it leaned away this much. But when you look at this picture, what is the most impressive feature in your left side peripheral vision? It's not actually this little gap. The most impressive feature, which it's not up to you, you don't get to choose this, it's just automatic. What sticks out in your brain more than anything else is this building. So now your brain assumes that this is the nearest vertical line, and because of that, look at how far away this building is leaned. These are actually the same picture. I literally did Control-C, Control-V. That's copy-paste. The shading's the same, the angles, all the rest of that's the same. Same picture twice. But your brain says, oh, there's vertical. Look at how much farther away we are. That one's leaning more. And so this stuff's actually kind of fun. It's real science. When you figure out what tricks the brain, you can start to back up into how the brain is wired, how the brain functions. They study this in psych classes. So if you're into that, take a psych class in college.